Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 12, 2025, which was about 3 days ago. The standout idea is a one-step generator that replaces the VAE decoder, so a fixed-size latent can be turned into images at any resolution, cutting 4K generation to under 10 seconds. The paper is titled InfGen, a resolution-agnostic paradigm for scalable image synthesis. And as we will see later, the results are really impressive. Beyond speed, the approach generalizes across multiple diffusion backbones, boosts high-resolution quality, and avoids retraining the diffusion model altogether. Alright, Figure 1 makes the promise concrete. A single fixed latent decodes into crisp, photorealistic images across many shapes and sizes, so image quality holds while resolution varies. The collage showcases tall, wide, and square formats, which matters because aspect ratio flexibility is often where generators stumble. The visual diversity suggests strong detail retention and consistent style across scales. So, Figure 2 shows that the one-step decoder slashes inference time for large images, which means creators get 4K outputs in seconds instead of minutes. The chart uses a logarithmic vertical axis, which spaces values by powers of 10, so big gaps are easier to compare. InfGen with DI-T sits far left in each group, staying under 10 seconds at 4K. Competing methods jump to tens or hundreds of seconds as resolution increases. Well, Figure 3 explains how the system learns and then generates at any size, which matters because a single compact latent drives all resolutions. The left pipeline shows training that maps a fixed latent to many shapes using a transformer decoder with mask tokens as queries. Mask tokens act like empty canvas patches that request content. The right panel shows plug-and-play inference across different diffusion backbones, so the same decoder outputs candles or cats at varied sizes in one step. So Table 1 spells out safe scaling steps for training-free extrapolation, which means repeatedly re-encoding and enlarging the image without retraining. The guidance says a 64x64 latent supports outputs trained up to 2048 and reliably extrapolates to 4096 when each step scales by no more than about 2. The 32x32 latent tops out much lower, so the 64x64 route is the practical path to 4K. Wrapping up, 2 takeaways stand out. The one-step decoder turns a fixed-size latent into any resolution with strong fidelity, and the speed-up is dramatic, bringing 4K to under 10 seconds while working across many diffusion backbones. The broader implication is practical, scalable, ultra-high-resolution creation. That is it for the AI Research Roundup. I am Alex. Thanks for listening.